now as well?
Yes, just one moment. I'll just add that. And thanks, Ali, for inviting me.
Also, this guy has built a plane from the ground up. So not just a radio station, but I remember hearing him tell me stories about the plane he built from the ground up. So that's a pretty impressive feat. And you still take rides in it, right?
Yeah, and we flew a couple. It's my best friend's plane. We built it together. It's made of aluminium, and we've flown it to Tasmania overseas, and flown it Lake Air, Perth, upside down, so it's aerobatic rated as well.
Seriously awesome, though. I can't imagine building a plane, but that is great. I love it. I'll have to get some tips one day, maybe. All right, Darryl, we'll let you take it away. Thanks for joining us.
Right, thanks for that. And by the way, if anyone wants a copy of my presentation, please let me know and I'll send you the PDF. Basically, I'm an electrical engineer and ham radio operator. I've been a Linux kernel hacker since the days of Minix. For those who haven't heard of Minix, that goes back to the early 90s. I've been doing wireless TCP/IP and IoT since about then as well. My undergrad thesis was on half-duplex spread spectrum radio networks, commonly called Wi-Fi these days. I'm an underworked consultant, and some of the projects I've been involved with are temperature monitoring in vehicles, maintenance of underground road tunnels, ground-to-air communications, in-building coverage with mobile networks, and also talking about here, I'm a volunteer engineer at 2NBC. Basically, this is a bit different from your normal sort of IoT. It's more of an industrial thing. The things being controlled are pieces of radio gear. And basically, thanks to IoT, the entire radio station can be operated remotely. And given that we're in the COVID environment, this has been very, very useful. We haven't really had to use it much, but we've got it there just in case. The radio station itself was one of the first community radio stations, and it's wasn't located at Narwee. Here's one of the old racks from the equipment and from the old station. And thankfully, early 2018, we got a new building in Cogra. And basically, this allowed us to replace all the equipment. Most of the equipment was getting up there in age. Even the microwave link between the studio and the transmitter site was actually Betamax hi-fi video signal, and we used that to transmit the audio signal over a video link. So it was hacked together and needed to be basically thrown out and restarted again. The new studio basically has two on-air studios, a production one which has transmitter link equipment, recording, some streaming for iHeartRadio, and an open plan office. And by the way, it was literally next door to the telephone exchange at our railway station. So much so that when we got the ADSL originally installed, we said to the guy, can you meet us out the back of the telephone exchange and we'll let you in the back door. It was that good. The particular site was pretty good, and the previous customer left a heap of equipment there. So they even left adjustable height desks, which we then modified, and we had some accidents with a circular saw so that they turned out to be exactly what we needed. All right. So basically, the studio itself now has fiber to the curb, which, by the way, was installed literally the day before the lockdown started. There were some issues that created for us, but that they've been fixed. We found some SIP issues between the transmitter site and the studio, which caused us some major issues, but we replaced some equipment and have got things working. Basically, we run a managed network using the Ubiquity Unify solution, which means that I can log on to my iPad from home or anywhere in the world and reconfigure equipment. The studios themselves have got these things called AEQ capital IP mixers, and they've got this thing called Dante. Dante is an Australian technology. I think it came out of Canon, but I'll talk a bit more about that in a minute. Basically, it's a audio over Ethernet technology that sends, basically it's designed to destroy networks. It sends uncompressed audio in a network, and you can have up to about 512 streams on a 10 gig link. There's a production studio, which has a PC on a timer because most of the programming is actually pre-recorded. Makes it really, so you might go into there thinking that there's announcers all the time. No, there's basically the radio station's on 24 hours a day, but there are only people there business hours generally, and people pre-record their programs, and you'd never know. With the new station, basically we've got 3 networks. Everything these days runs TCP. We've got color-coded networks. For those who recognize the coloring, we've got the studio, which is the secure network, because we don't want anyone being able to hack that, so it's secure. We've got the blue network for office, and then we've got a network at the transmitter site. The only equipment, only studio equipment's on the studio network, and we've got unified Wi-Fi at both sites. At the transmitter site, we've actually got a very small network. We've only got about 4 pieces of equipment: the transmitter, some audio equipment, some streaming equipment, and the Wi-Fi. And the ADSL equipment as well. That was fun getting that installed, and we're having fun in getting that upgraded to NBN. Basically, the address of that is in a cabinet, literally underneath a concrete water tower in Sydney. So, and it's about 80 metres from the street. So we're in the process of trying to get that upgraded to NBN, but there are some challenges. All right. The studios, basically they've got the Dante interface, and you'll see in this photo in the corner, there's basically an industrial light pole that you would see for in a factory. That tells you when microphones are on and those sorts of things. Normally, the screen on the wall there would show a VU meter, and there's lots and lots of Cat5 cables coming into this room. However, the one thing about this room, this studio, is that no audio actually leaves as analog audio. Everything goes out comes in, goes out over Ethernet. Everything's digitized, which means I can log in and see exactly what's happening. If I was to do this again, basically, I think I had about 10 Cat5 cables coming into this room. If I was doing it again, I'd basically have 1 or 2 Cat5 cables and then put a managed PoE switch in this room just to do everything. The technology in the last 2.5 years has changed so much that that's now a viable option, and I also understand the technology a bit more. Now I'm going to talk about a bit more about Dante. And while I'm talking, you might want to have a look at this screen here. This is a virtual patch panel. Every single piece of Dante equipment has got multiple audio streams. Commonly, there might be 16 audio streams in, 16 out. It's an Australian designed technology. They're actually based at Ultimo, I believe, in Sydney. And mostly it's been implemented on programmable hardware, and it allows you to send uncompressed audio. It's millisecond accurate, so it's accurate to the millisecond that every single audio packet in the network comes out at exactly the same time. But the thing is, it also breaks networks because you can't use quality of service on Dante. It will just break things. It'll work multicast, unicast. Multicast is good if you have more than one channel wanting to receive the audio, and your network equipment is configured properly. And it's also great. You can use what's called a virtual sound card, which you can have up to 64 inputs and 64 outputs on it. If you've ever taken a train in Sydney, they actually use it on the platforms to get the audio around. And as a strange device, there are actually power over Ethernet speakers available with Dante. It's a pretty interesting technology to play with, and something that you won't normally come across. It can be expensive, but doesn't necessarily have to be. But it does some very interesting stuff. Being able to run 512 audio links from a 1 gig network link is pretty spectacular. And then you can just cross-connect them. Basically, in each studio, we've got microphones, a telephone, and believe it or not, CD player. And so not many people are using CD player anymore, but we also have people using mini discs and turntables. Thankfully, we're starting to wean people away from that, and we've actually got a trolley for the mini disc and turntables. So if you want to use them, you actually have to use a trolley to bring them in. And one of the things that we are finding more and more is that people are bringing stuff in on USB to play, especially for live programs. And they'll have like 3 or 4 USB sticks coming in, plugged in, and then they do a live program. It's rather spectacular and rather interesting. Basically, the mixing console there is a pure power over Ethernet device. You can unplug it from its base unit, and it will still operate. There's actually an iPad interface for that, so you can control it from home. So during COVID, we have been controlling it from home, and then you can also control it from the studio PC and remote desktop in. This allows you to do basically anything you want to as if you're in the studio. You can even do things like ring up the studio telephone, answer it on the mixing panel remotely, and then mix yourself remote. So it creates a great mobile worker environment. This at the moment, it's connected through a VPN, and it's great on the iPad. The only thing is I haven't quite got the VU meters, the level meters working on the iPad, but it doesn't really matter. Okay, out at the transmitter site, we've got a ADSL link, as I mentioned, and we run a Ubiquiti site-to-site VPN. Basically, this allows us to run a point-to-point private network, despite the fact that they're both public internet connections, and we've got some basically broadcast quality codecs, audio to audio equipment on both ends. Unfortunately, we come out as analog and then go back to in the transmitter or in the processing, and then it goes back to digital and analog and digital a few times in the transmitter site. However, we don't seem to lose much quality for that, which is good. The admin rack, this is an old version of it. We've upgraded a tiny bit since then. This is where all the cables come in. Pink for the secure network, which is for studio. The admin network's blue. Phone cables there are beige, although we've just upgraded to a 3CX phone system. We've also got a thing called a remote admin terminal, which basically has a copy of all the control software and remote admin or remote desktop into it. One of the other strange bits of equipment we've got is the access control system. Basically, if you want to get into the building, you have to use your Opal card. Well, you can use some other cards, but what we decided was that we can read the the electronic serial number from Opal cards and use them to control as RFID access control. This means that no one wants to share their Opal card, and therefore we're pretty assured of the right person. The people entering the building are the ones who are registered. And thanks to this, we also know who's visiting the studio. And this also now does the sign-in, sign-out for COVID so that we know who's been on site. And also we've got rid of the key for the toilets. And so there's an access control for it. Just because the key itself is a potential hazard for COVID. Remote working, basically, we've got things fairly well set up so that you can remote into almost all the equipment. The studios can be quickly upgraded remotely, and we've got 2 different remote admin servers. We've got one set of servers that then uses VNC to connect to other machines. We found that was a bit better so that it didn't drop audio on and off. And that's used by announcers if we need to. And then we've got the remote admin terminal, which is mostly used for the sort of me and the station manager just to reconfigure things. So we're fairly well separated everything. This just gives you an idea of that there's a heap of software on the remote admin terminal. Basically, if things are working, if the network's up, we can fix it remotely generally. If not, we have to come in and do the work. Basically, things that on their security console, network management, compressor control for the transmitter control, including setting the station ID, everything, mixer configuration, outside broadcast configuration, everything. So it's a pretty well remote operation now. The remote worker server, we've installed Type VNC onto it, and you remote desktop in. So Type VNC doesn't cut out the audio and doesn't cut out doesn't log out computers at the other end. So we've got rid of TeamViewer. And one of the cute things is that we've set an orange background on that machine just to remind people that what server you're on. And that little screen there just shows the remote scheduling of overnight programs, just as an example. Let's see all right, working from home was a bit of a challenge. Thankfully, we got NBN installed just before the at the studio just before the lockdown, and so we've got a few options for doing remote work, just depending on sorts of things we want to do. We've got some old equipment called a tie line outside broadcast unit, but we've also worked out that there's some PC software where you can actually connect into the entire system using some VoIP software, and it goes straight into the mixer. Basically, this is almost 10 years old equipment. Requires a remote unit, which means it limits who can actually have it. One thing we found, if we get rid of the remote unit, you can actually dial into it through a VoIP phone or PC software. One of the other cute things we did was upgrade that device to run Dante. This is the little graphic there is a power over Ethernet to XLR converter. You can get mono units and stereo ones. Basically, this gets you very cheaply gets you your audio sources, your legacy audio sources, into the VoIP world. And by running power over Ethernet, you don't need to run analog mic cables anymore. You can plug one of these units straight into a microphone on a stage, for instance, and just run power over Ethernet to the stage. This is the sort of thing where our announcers could actually use a VoIP, in this case microsip, just to dial into the outside broadcast unit, and then they have to log in, put a fader up, and they're on air. It's fairly secure because you need to know all the details, plus you need access to the fader. Blink works a bit better and has an Opus codec. So we've got one of the machines has got in each studio has got this software, the Blink software in, and it allows you to run higher quality, more broadcast quality remotely. So it works really well. Phone system, we upgraded the phone system as well. For us, it was free because we've got less than 8 simultaneous calls, and that's worked really well. There's an app for that. I won't go into too much detail, but we've also got analog terminal adapters for each of the studios so that you can actually put up to 2 phone calls to air at once, have them talking to each other. That works really well. Just going through this. I think I've talked about that basically. Documentation. One of the things is that we did I mostly did when I built the station, was documented everything. There's a Google Docs manual. It's several hundred pages. It's constantly updated and constantly out of date. Lots and lots of screenshots. Basically, any configuration goes into a screenshot and is stored there, because you can imagine with a radio station, the last one was 40 years old when we rebuilt it. This one's going to last a similar length, we hope. So there's a lot to document. So I'm trying to play it forward for the next person. Lessons. The access control is great, but more doors are needed. Dante is amazing. I'd probably change a bit more some of the equipment, and we'll do that at some stage. Basically, what I also found is that you always install more cable than is needed. There are some cables in there that I can't remember what they're used for, but anyway. The alarm, one of the strange things is we've installed a security system. It reports if the power goes out in the building. And that's been very, very useful. We also configured, put an interface on the alarm system. It's got some relay outputs. So you can SMS the alarm system. It can actually do a power cycle on up to 4 bits of equipment. And the last thing, or one of the other things we've got there is a loss of audio source detector at the transmitter site. This was absolutely amazing. It listens just to the analog audio signal, and if it disappears after 30 seconds, plays an MP3. And we've got about 8 hours of MP3, and this allows me to actually do maintenance, which is useful, and means that there's actually audio at 2 a.m. if I'm doing audio maintenance at 2 a.m. for the few people who are listening to it. Anyway, thanks for that. That's the end. There's more stuff at the end of the presentation if you want it, with some diagrams on how things are set up. But just email me, and there's more some more photos as well. So thank you.
No, Darryl, thank you. That was great. I mean, that's definitely a topic that I haven't really thought of or heard of before. That's a lie. I did start off my engineering stuff in a radio station, but there's so much there to be unpacked. So thank you for going over it with us.